clicking around to find where this record button was.
Yeah. So, gosh, where's the best way to start with this? So the idea is, so what we wanted to do was have a version of Effection that has the structural concurrency guarantees baked directly into the delimited continuation stack. So right now, the version 3.0 is based on, and I don't have a presentation or anything like that. And so a lot of this stuff is it requires a lot of visuals. So just stop me if something's not clear, because I don't have any visuals. But right now we have two separate systems. There's like the low-level delimited continuation library that lets us do non-local flow control and lets us essentially not have to use any callbacks. So in version 2 of Effection, everything was callback based. And so it was extremely difficult to maintain because the mental model of what needed to happen when, and essentially which resources, like the sequence of resources, and when an event finished, or sorry, a frame finished, what was the next thing that you had to do, all kind of had to be maintained in a big mess of global state that was associated with the shared state that was associated with the task. And so by having it based on a delimited continuation library, then the actual life cycle of each task was very, very clear. So you start the task, you run its iterator. However the iterator finishes, then we iterate through all of the child tasks, shut them down, and then we can pass our value back to our parent. And so that made that aspect of it, and that's what's in currently, like the frame.ts, like that became one, became one function. Essentially, every life cycle of every, and I'm kind of using frame and task and scope interchangeably, because they've had different meanings over the different versions of Effection, became one function, essentially one generator function. However, there are some problems with this. One, there's still maintainability issues, because you've got like these two separate paradigms. It's like when you see a generator function, you have to think, well, am I using just a normal generator function to get a sequence of values? Am I using the low-level continuation generator function to have a, what it calls a computation, which is a sequence of controls? Or am I talking about an Effection operation, which is a sequence of instructions? And if you look, really the controls and the instructions are very, very similar in what they do. And there's a lot of duplication there. So we essentially are kind of, and if you look at that duplication as realized in the sense that we have in the, for the continuation library, we're reducing a set of controls, and then inside each frame of every like Effection process, we're we are implementing a reduction stack, which is then based on this other reduction stack. So there's all these reduction stacks that are happening as you're doing Effection. And there were, a lot of memory, like it was a memory hog. Now we've done a lot of optimization to make it a lot less hogging of memory. But there's the opportunity to simplify the code, reduce the amount of code, reduce the amount of memory that we're using, and just make it a lot more simple if we can just have the structural concurrency guarantees baked right onto the continuation library. And so that's what this spike is about, is basically having a single stack of instructions that you're reducing for every single entry point. So, which corresponds roughly to, in Effection, where you would call run. So you're bootstrapping into Effection and then executing the instructions, and you basically have a stack of coroutines that you're evaluating, and no matter how deep that stack goes, it's just one. Or how many children you spawn off, it's always just one. It's just one stack that you're going off of. And you can start and restop it, so you can like re-enter that stack reduction, which is what you would do like with a timeout or an event handler, and so on and so forth. So that's the idea. And so you can see, if we go, let me just share my screen now. There we go. Share the screen. So if we look at the continuation library, can everybody see my screen okay?
Yeah, sorry, Charles, let me just ask a quick question. Rix and Siva, are you guys comfortable at the level that we're starting at? Do we need, is there anything else that would be helpful before we dive down at the code?
All good for me because I've seen this before.
Okay.
Yeah.
The problem you're trying to solve is trying to consolidate different frames into one stack, right? So that's the main goal of this one.
Right.
Yeah, I kind of understand that. Yeah.
Yeah. And yeah, so multiple frames into a single stack, and then just have one paradigm. Because if you look, actually, this like stack reduction algorithm that we have here, we're kind of this is from the continuation library. And then, so you can see we're iterating over each stack, and then, we're getting the next thunk off of the generator. If we go over to like Effection, we've got kind of this, in here, we've got this parallel thing that's like almost the same, but not quite. It's a different instruction set. But it's very reminiscent. And so, yes, we've got not only a conceptual unification, but also like a runtime unification. So instead of, you got one stack, you have one stack per frame in current Effection, and we want to have one stack per entry point, and then also, yeah, conceptually unify it. So we've only got one instruction set that we have to worry about. So like here, we're talking in terms of resets and shifts and necks and throws, and here we're talking about what is it, spawned, and where's that we actually, I'm not sure it's evaluate here. Oh, right, we get the instruction here. So yeah, that's that's what this is about. So what I did was I actually went off of the, so if we look here, this is my new thing that's in this scoped Effection. And so this is, you can see like has this concept of continuation, instruction, and operation, but instead of having computations and controls like you do in the continuation library, you just have Effection operations. And so if you look in the types, you can see that these are very, very similar. Here's the operation type, straight from Effection. And here's the continuation type, which is, I have some value, and then that I take as an argument, and that it returns an operation that yields my return type. And so if I look at, I think I like the continuation test here, this is essentially the continuation library suite, but it's It's evaluating these delimited continuations directly. So it's that I can use for basically doing non-local control. And so the way it works is very similar. I actually changed the implementation a little bit. It's based, I think I posted in Slack. Maybe I didn't. Let's see, let me just look at is it here? No, where's the, yeah. I think oh yeah, okay, there it is. So basically I took this implementation right here, which is the original implementation of oops, sorry, which is the original implementation in mini Ocaml. Oops, okay, it doesn't like that. There we go. I can't cut and paste from that buffer. And so this is basically this is a pretty approachable paper. It just shows how they implemented the stack. Gives a little bit of background, but then they've got some good visuals of how they implement the stack. And so basically what they do is we have coroutines, and then when you do a shift, you press when you do a reset, you basically put a reset marker onto the stack, and that lets you know that when I capture continuation with shift, I need to capture all of the coroutines going up to the reset marker, and I take those and I save them in memory, so that when then you resume it, you take that whole thing and then you put it back onto the top of the stack, and then you keep going. And then so that got me the basic continuation, and then here's where I added the structural concurrency element, but I didn't get it quite right. But again, this is a spike. So basically what happens is whenever you create a new subroutine, so these routines represent coroutines. You can see here when we do a reset, we're pushing onto the stack, we're pushing the reset marker, and we're pushing the subroutine. Otherwise, if it's a shift, we basically pop off of the stack until we get to a reset, and then we create the continuation, which then captures the caller of the continuation, and then puts that along with the frames that it had captured back onto the set, and then puts a new reset on there, so that the continuation evaluates in its own context. And then yeah, and then here's where we start the new routine operating. So it's actually really simple. It's unbelievably simple. But what we did is whenever you create, so what I did here, and again, this is wrong, is we create a routine. Whenever you call new routine, you can pass the parent. So here, like, we're passing in the parent. And then what I did here, this was just like a cheat, is like whenever a routine finishes, if it has any subroutines, then we're gonna we're gonna create a new routine to exit that subroutine onto the stack. And so then it will only return after all of the subroutines have been destroyed. But I don't think that's quite right. I think that what we want to do, and I was posting some of these in Discord yesterday, I think what we want to do is we want the scope to be a separate thing on the stack, so that I can have better control over it. So, for example, I'm trying to think of a good way. Like, so right now, if like basically we want to have some way of saying like here's where a scope starts, and my routines can run and run and run, but whenever the coroutine that's associated with the scope exits and that leaves and is killed, then every subroutine underneath it needs to die or something like that. But otherwise you can't really like it. I'm trying to think of a good way to express this. There's just some cases where, like, especially with these non-local controls that you're like jumping around, where you don't want just because something returns that everything that was created underneath it is automatically killed. Maybe we could do something. We could automatically insert a scope at every reset. I'm not exactly sure, but not a shift. It's hard to say. Anyway, we want to be able to represent, you know, that scope on the stack as well. But I also don't think that we want to necessarily represent scope, because like whenever you call a reset, that's going to create a new iterator, and it's also going to break the stack trace. So what we, you know, one of the original purposes of this spike was that we wanted to be able to say, like, I want to delineate something is happening in a scope, and any resources that are set up during that scope are torn down when you exit the scope. But I don't want to actually change I don't want to change the iterator. I don't want to create a new iteration. I just want to yield star so that I preserve the stack trace. So that's a big word salad. Like I said, I don't have any visuals just because there's a lot of work going on. I've got other stuff that I've been working on the last couple of weeks. So I haven't had a chance to sit with this or like prepare anything.
Do you guys have any questions? I think that if I wanted to set up this call just so we have a chance to kind of talk about the spike that Charles, you put together. But if we're not, I mean, we can do, you know, we could just do have just free form conversation if there are any questions. If there aren't, then we could just do another follow-up conversation when you had more chance to put something together.
Yeah.
Have you considered like not using reset and shift at all?
Like you using a totally different instruction set.
Yeah, just express all the continuation policies with some specific instructions instead of constructing them using reset and shift.
Yes, I have. And it might be worth putting a spike together with that as well. The nice thing about shift and reset is they really account for any type of control that you might want to have in the future, like that we haven't thought about yet. Like chances are you can express it with shift and reset, which is one of the reasons I'm keen to at least explore if we can use it. But absolutely, I have definitely thought, like, what if we just made spawn an instruction, and what if we just made what if we made these things instructions directly, like the kind of the primitives? What if we made call or scoped? Just those, we might just get away with saying there's all we need is scoped and spawn, and that's it.
Yeah, because shift and reset is not free at runtime. Whenever you have to suspend a generator and resume it later, there's runtime overhead at the engine level. It has to copy the register context, local variables whenever it does that. So like the more generator we suspend and resume, the more runtime overhead there is.
Yeah. Yeah, no, I've definitely thought about that, and I think um, it would be worth uh, it would be worth like yeah, it would be worth experimenting. Like, what would be a minimal instruction set that we would need to implement just to get the affection primitives without shift and reset. Um, One thing I do think is important is you definitely want something that's like shift. So right now, I would say the closest thing is action, because you do want to do an early return. So you see this, for example, in uh, Effection, like the main function. We go here and we look at main. You know, one of the things that it does is the very first thing it does is it creates an action at the very top. And so this is so that you can exit early without, you know, doing the classic thing of Node.js or any other thing that exposes an exit primitive where you basically shoot the process in the heart and don't give it any chance to do any teardown. You just tell the event loop to finish immediately. Whereas here, what we're doing is we're capturing an exit point. We're basically capturing a continuation at the very highest level, and then we're resolving that when you call exit. But what it means is everything, as you exit, then everything tears down the way it's supposed
Right.
to.
Right, but
Um,
that doesn't necessarily have to be a shift and reset
no, it
implementation,
doesn't.
right?
It doesn't.
I feel like all we care about is how, like, instructions should only be like um, a recipe of how to manipulate the stack.
Mhm.
That's it. And shift and reset is just an abstraction of that.
Yeah.
It's a tool to express that kind of policy, for you to manipulate the stack in a expression way. But
Mhm.
if you have a lot of instruction primitives that you have defined behavior of how it should manipulate the stack, you don't have to use shift and reset.
No, you don't.
Yeah.
It's just that it's the reason, like I said, the reason uh, I've used it before is like there's no flow control that I've encountered that can't be expressed with shift and reset. Whereas if we choose something else, we might actually get ourselves boxed into a corner. Um, but that said, I think it is worth a spike of just doing direct stack reduction with, maybe, like I said, what we need is just we need an action instruction and a spawn instruction, or a scope instruction and a spawn instruction. Um, I'm wondering if we might even be, yeah. And so, like, we might be able to get away with nothing but that. I think it's definitely worth exploring, like how far we could go just by doing instructions directly. And really, that's the approach that I think V2 takes, or V3 takes. If we look in the types, um, so what is the type of instruction? Uh, oh, okay. You know what? I didn't. Instruction used to be there was specific instructions. Now it's actually a function. Um, okay, interesting.
We are not seeing the screen if you're sharing.
Oh, you're not seeing the screen.
Yeah.
It used to be, so when in the very first version of let's see. So actually an instruction now is just a function that returns a sequence of shift and resets. But if we actually, at the very first version of Effection 3, when I started doing it as basically an instruction set, is there was a spawn instruction, there was an action instruction, there was I can't remember what other instructions. There was a suspend instruction, and we might be able to get back to that. I think what I needed was a little more flexibility because we had these two separate stacks, and I needed to basically run some custom glue code to stitch those stacks together to make sure that errors were propagated properly and things like that. But if we have one stack, then that probably wouldn't be a problem, and we can go back to having explicit instructions. And maybe we can look at one of the test suites. This is like the one that has most of the functionality. You know, here, like we basically, we could have an instruction for like awaiting on a promise. We could have an await instruction. We probably would want to have some sort of like suspend instruction where when you suspend is what you basically just get a way to re-enter back into the stack. One of the things that I was thinking about is we could probably get away, make suspend a lot simpler, where you basically suspend and then you get a resolve, reject if you want. Like that. So this is right now there's this pause. It's essentially something like that, where you pause and then you get the resolve and the reject. I'm thinking we should probably, rather than have a separate pause function, we can just say you suspend and then you get a thing to re-enter stack reduction.
Yeah, I like that.
So we would need a suspend instruction. We would need a spawn, probably a spawn instruction. And so here's something that I really want to solve and make sure that we can account for solving this is, this got into those spikes that I was doing, is like, how can we elegantly express all, where you can do things like pass resources to all. So let me, so actually let me just put this right in here. So if I have, I can't do export at this level. Okay, so anyway, so what's tricky about this is that it causes a lot of problems. Is currently I can't do anything like this. Or sorry, try. Because what's going to happen here is if I have an operation that throws an exception, so there's two things that happen that's a problem with all. Is one, I can't catch errors because it spawns this process, and so it doesn't actually create an error boundary between all and the thing that you're doing. And then the other thing is that if I want to create, like, let's say I've got like 3 resources. If I run those resource operations, it's going to run their initializers, and then it's going to return me the handles, but they're all going to be dead. I can't spawn anything inside of an all, which is kind of annoying. Maybe this more clearly expresses it, because in order to run things asynchronously or run things concurrently, all actually spawns processes. So if we look at all, it's actually spawning each one in its own thing. But then I get all the results and I return them, and that's great if these things aren't meant to, like, if this isn't like a server that I want to start. And so this is like a recurring issue. There's no way to, quote unquote, promote the scope or say like, I want to spawn this thing, and then I want to, like, almost have like a transaction where I transfer ownership upwards. So, because if one of these operations fails, well, then I don't want to be spawning any of this stuff in a parent scope. I want them to either all succeed and then all promote, or just all fail and like terminate immediately. So like if I have 10 operations that spawn something, and 3 of them succeed and 7 of them, or 9 of them succeed and 1 of them fail, I don't want any of those spawn processes to survive the call to all.
Yeah.
Oh, and here's, okay, so we can catch it because we explicitly wrap it in a call. I see. But it's still that, right? But that would means nothing can survive this thing. But what I really want to do is I want to, like, once I get to this point without error, I want to say like, I want to promote the scope or something like that. So what I was playing around with is this idea of having a scoped function, and then being able to promote and say basically this scope gets folded into its parent. Or we could do the opposite, where you have a transaction and then you have to commit. And if you don't commit, then they all get killed.
Isn't the yield start task going to do that already? If it fails, then
yes, this is going to cause it to fail.
Yeah, if it failed, then it should tear down all the child process.
Yes, that's true. Because it's going to, but there's no way to establish. So let's say, so the problem with this is right now is if, yeah, that's true. But if the problem that we have is that if, okay, here's where it comes into it's more an issue with race, right? Because if this fails, it's right, it's going to crash the parent. And so that we don't have to worry about. It's going to crash all of them. It's going to tear them all down. But we can't just run this. It's more a problem with race. Let's look at race.
Yeah, you want it to crash as soon as possible when any one of those fail. I kind of get that.
And
yeah. So
and if, like, let's say, and I want to catch, like, let's say I want to catch the error. So if I want to, like, let's say I have a try catch around all, or a try catch around race, and let's say that, like, I'm racing 10 things against each other. If 3 of them, sorry, the first one that succeeds, I guess, like, if they're racing and, like, those things are there, like, as part of their race, they're actually creating resources. And so, like, let's say I've got 10 things and, they're creating resources, and I have the one that wins. I want to promote, I want to return it, and I want to take the resources that it created, and I want to, like, put them in the parent scope, but all the resources of the losers need to be shut down. Does that make sense?
Yeah.
Like let's say I have my, op one, and it's like, R1 equals yield, use resource one. And then, it's like return some computation. Or, return, I don't know, something like that. So like, and we're going to erase three of these things against each other. So what do I do in this situation if, like, let's say this one wins, but these other two are stuck here? Like I need the winners. I need these of the winner to be alive, and I need these of the loser to be dead.
I don't see a problem there, because race will create its own scope and it will manage all that. So it can capture all the arrows. It doesn't matter if it's if it succeed or not. As long as the first one succeed, it would just starting to tear down the other two. It doesn't care about whatever they succeed or not.
Well, so that's true, except I'm also I'm like, if you in this situation, like action creates its own like boundary, and so nothing can outlive action. So as soon as I resolve, they all die. But I want to keep these alive for the winner. So right now we've got like the way things live now, nothing can escape the action.
I see.
Because the action basically sets a scope boundary, and it sets a so it's the same way with call. But the thing about action is it establishes, action is kind of like the Effection version of shift, where you're establishing a non-local return.
I think there should be two kind of scope. One is asynchronous arrow code scope. That is, when you spawn something, the arrow will propagate to that scope. It will catch it. So every asynchronous arrow is being catched by some arrow scope, and then the other scope is a resource scope. So as long as you close that scope, everything in that resource scope is being teared down. Yeah, and we also have like lexical scope, execution scope, those kind of stuff. I think we need to like distinguish them.
So how would I if I set up a resource scope here, like the thing is I needed separate resource scopes for each of these operations that I'm racing. But then how do I tell, like, this resource scope that I want to throw those resource scopes away, but I don't want to like I don't want to. I want the. Am I? So like here we have a resource scope that's established by the action, or sorry, the action inherits the resource scope of its parent.
Yeah.
So
you don't
so
you don't
then
want to create a new resource scope at this level. You just want to create a error scope.
right. I see. So this is like right. So this is basically a concurrency scope, and so the only time once the resource operation succeeds, then it gets put into the resource scope. Like once the initializer is complete. Right. Mm-hmm. So then basically both all and race would establish a new resource scope. Or sorry, would not establish a new resource scope, but they would establish a new concurrency scope.
Yeah.
So nothing can, there can be nothing running, but right, okay. Yeah, I can see that. So then this wouldn't need to change at all. Right. Operation, and I'm trying to think this, because right now you just can't use resources and all, erase and all, to create resources, which is really annoying. Now, let me see, what was he complaining about? And there was actually a, all creates a new scope. So what he wanted to do was he actually wanted to spawn inside of an all. And he's like, here's what I want to do is for every operation, I want to spawn these tasks. But then the problem is the tasks were immediately killed. But if we have two separate scopes and we have like a spawn scope and a resource scope, that's still not going to solve his problem.
Well,
although this isn't really like, yeah.
A spawn scope doesn't inherit doesn't create a new resource scope. That's what I say. You should not
Right.
create a new resource scope when you spawn. And
Right.
all also doesn't create its own resource scope.
Right.
So everything will be propagated outside.
Right. And here, right. Okay, no, that would work. That would work. Right. Because here, what's happening is we're basically got it. The problem here is we have a double spawn. But we're still going to have a double spawn because the thing is, what he's doing is he's creating a spawn operation. And so then this operation right here is actually a spawn. So we're spawning inside the spawn. And so what happens is because we're spawning inside the spawn, this returns immediately. And sorry, let's go to all. His problem was with all. Is we're immediately spawning, but since this is a spawn, the spawn returns immediately, and then it kills the thing that it spawned.
Yeah, the problem is the core operation is creating both a resource scope and a concurrency scope. You're not distinguishing them, so it kills everything when it returns. So that's spawn. So if you distinguish resource scope and the concurrency scope, then like call and spawn, they will all just create concurrency scope, not resource. Well, call. I don't know about call. I'm not sure about that.
Let's get rid of call here. Yeah. Let's.
Yeah.
I don't think call is the right thing.
Yeah, yeah, and then everything will be just propagating out, so that'll be just fine.
So, but this thing was so. But the problem is that this thing is a spawn.
Yeah.
Then we've got a spawn within a spawn. And so what ends up happening is this spawn returns immediately, but because this is spawned, this like you still can't do spawn. Like the real question is what should happen when you say this?
Yeah, I think that's right. Yeah. You cannot. Yeah, you cannot have something outlive its parent. Unless you attach it to something the parent is running. So yeah, probably it should pass down the scope to whatever he's trying to spawn off, and then just attach whatever he wants to spawn that outlive the thing, and then to some parent scope. So
Right.
it doesn't violate the concurrency, the structural concurrency.
Yeah, I mean, what you can always do is you can say,
yeah,
you can capture the current scope, and then we could put we could say scope.spawn.
Yeah, like that.
Or something like that. And I'm trying to think if run. Yeah, right. We should put a scope spawn operation directly on scope, and then that's the way you would do it if you wanted to live. And so then his ops, he basically would say all. That's how that solves the problem pretty clearly.
Yep.
Okay. So right. So yeah, so having a separate resource scope and a separate spawn scope, or yeah, concurrency scope. Be pretty right. And by default, right, we would just let. So this would be like a concurrency scope, or I don't know how we would. What the API is for it. So I think that's a good next step, is to try and what would it be like if we were what would be the instructions that we would need in order to do this kind of minimal API. Yeah, I mean the nice thing about having shift and reset too is it does let you experiment with APIs that we could. I mean, basically lets you experiment with APIs and different control structures without having to implement new instructions and kind of figure them out. It definitely gives you a lot of freedom in terms of figuring out how things should fit together.
Yes, shift and reset is more general approach. Yeah, you can implement all kinds of things, but at a runtime cost, of course.
I mean, I wonder if there's a possibility. So I think what the next step is, we should try and let's we should try and make an example that just has a few instructions, and then see if because the Effection API is actually quite small, and if we have some way of controlling the scope and being able to spawn and then everything else is expressed in terms of those primitives. I think there's probably not that much work to do.
Yeah.
So, because like ultimately, like this is not, it's not that much code, and so so yeah, it would be
the great thing about structural concurrency is that you rely on all the JS syntax, JS like language features instead of implementing all set of logic operators like using
right.
functional operators. So you don't have to bear that responsibility of like expanding your whole API service to cover all the logic out there. You don't have to. It's already in language itself. So you just need to implement the very basic stuff, then it should work.
Right, exactly. Hey, I'm curious too. What do you think? Like the other thing that with this, if we do it on the stack, if we have a unified stack, we can actually do something in our for loops. If we have a thing on the stream, we can actually, because we get a return, it calls return on the iterator. We can just insert a item right onto the stack to tear down any, like we can basically implicitly put a like resource and concurrent, like we can basically put a resource scope. Like let's just say that we had this API. I'm not saying this is what we should do, but like right now you have to either put a call or an action or something to put a scope around the operation that happens in your loop. But we could, with this, we could actually implicitly put one, because what basically the runtime always recalls return on your iterator, and so we could have that call actually input a we could have that call put a thing inside the reduction stack to actually tear down anything that happened here.
If you break, would it also call return?
Yes, it does. Okay. It does. If there's an exception, if you call break, it does. But right now, like anything, this, you basically have your scope here, and I would think that if like I were proposing to TC39 that we make the structural concurrency, I would say every time you establish a scope every time you have curly brackets.
Well, I would not want that.
You wouldn't want that?
I don't want that because curly braces are very because right now you can add curly braces to anywhere, doesn't cause any problem, doesn't change any behavior, right? If you do that, then you are doing something like RAII, which TC39 is proposing one right now. And then suddenly, if you add a pair of curly braces to somewhere, it may change its behavior depending on what's written in there. So I don't want that kind of like detail to slip into our code review.
Right. I mean, it's not a big deal to be able to say yield scopes.
Yeah, I would like more explicit
scope management.
Syntax. Yeah, that's fine. I don't mind like writing a little bit more code if it makes things clear. That's fine.
Yeah. Okay. So it's a possibility, like if you were using each, we could implicitly make it so that resources don't escape, or like anything, like if you spawn,
Yeah, especially if you do like for that in curly brace level, there's no way to opt out. That's one thing.
Right. Well, the way you would opt out is you'd have to capture the scope. Same way you would with the all, you'd have to capture the scope outside the curly brace.
Right. That will actually be a lot more like cumbersome for me to write.
Yeah. But it would have the advantage that you wouldn't be able to, there's no foot guns.
It's probably better if you are able to capture the scope, but the proposal, the resource management proposal that TC39 proposed, there's no way to capture the scope. They deliberately
Yeah.
don't allow you to capture the scope. They give you a disposable stack thing, which acts like a scope, but it's not captured. It's creating a new thing. It's really hard to use that. I
Yeah.
really don't like that.
Yeah. It's not good. Um. So okay. Well, this is we can play around with that. But yeah, just being able to do this, have something like this where this actually like affects the current iteration, and then this thing gets basically yield starred, so that this like also is the preserves the stack trace is possible with if we all have one reduction stack, whereas
Yeah,
it's not possible today.
Stack trace, I think stack trace right now it works at the expense of yield star, which we know is like not performance. Um,
Right, is
uh,
problematic. I
yeah,
think we can introduce a star to that. Like I was thinking, if you have something that's not performance, we could we could we can do something like that where you can do a manual transform, and then we can uh, uh, which actually does the hoisting and just kind of
yeah,
trampolines down to the deepest star. Uh,
yeah. I
as long as
know.
so we would have like a
But
star instruction.
yeah, but at runtime you will still lose the cost stack. There's no way to.
Yes, yes.
Uh, I think eventually, if this gets popularity, I think it probably will make sense if we propose something to TC39 and add something that's will preserve call stack for coroutine resumption.
Mm-hmm.
That's in the spec and in engine and implementation that preserve it. Because right now they are able to do it for async await because they distinguish async function promise uh, as a special generator function.
Right.
And because the engine can chain these async coroutines using promise, where promise forms a chain of that uh, nested frame stack, call stack, and then it can walk the stack using promise chaining. Um, but generator function doesn't chain each other. Like there's no then you call, like there's no
Mm-hmm.
callback you use to chain each other, so you cannot walk the stack. So if we want to do this, we probably need to propose something that treat generator function distinct with general generators. Like generator function is distinct, just like async function is distinct. They are not general generators. They are function. They have a call stack, and then they can
Right.
chain each other. They can yield start each other, so that when they are chained together, you are able to walk the stack. There has to be something in the spec that allow us to do that, allow the engine to do that. Right now, there's no.
Mm-hmm.
Yeah.
Right. I mean, they could keep the stack. Oh, right, right. When you yield star, there's
Yeah,
obviously
there's
that check,
when
right?
you start, there's no trace in the uh like in in the structure of the runtime that tells you that you starting to something else to chain those stacks together. But when you do a await, there is a dot then that put the current resumption to the chain of that promise. So
Mm-hmm.
there's a trace in memory, and it can very easily walk that chain.
Mm-hmm. Mm. Right. Right.
Yeah,
Right. Right.
the async await call stack, they implemented at zero cost because of that.
Right. And right. And they're keeping the reference. So they're keeping a reference to the function that the promise came from. Too.
Yes. So when you await, right, you basically first we will suspend the current function,
Right.
and then it will put the thing in the suspend the continuation into the then clause of the promise you've been awaiting on.
Right.
So that will register the continuation on that promise, right? And then it will put that onto the event loop when it finished. So when the next loop comes, it look at the head of the event loop. Oh, right now I need to continue something I have suspended. And that continuation comes from a promise. It's a promise resumption. So you know which promise is being resumed and which continuation is being resumed. And then it knows where this promise comes from. And then you can chain together the whole thing.
Right. Yep. Absolutely. So, okay. All right. Well, I will try to throw together at least something this week. If anyone else wants to jump in, and maybe we could try and put together like a little instruction set in here. We don't have to use this spike that I have here. We could use, yeah. Let me turn the phones off. We could use this one. We could use something else too.
Yeah, great.
Siva, how about you? You still there?
Oh no, Siva dropped off. He had work meeting started 10 minutes ago.
Yeah. Okay. All right. Cool. Well, have a great weekend, everybody. Thanks for this.
Okay, great.
Yeah. Thanks. It was great discussion, and I'll upload the video probably to YouTube or something after. We'll start getting a collection of things as we design this.
Cool.
Thanks, everybody.
All right. Bye-bye.
Bye.